Hi, I'm Lizzie, and today I'm going to be teaching you antiderivatives along with my friend Vicky.
James.
And Brittany! We're in Lieutenant Colonel Bushall's M3 Bravo class. To further understand this, we must first define what an antiderivative is. According to the book on page 344, an antiderivative is defined as a function of big F is called an antiderivative of little f on an interval of I if f prime is equal to f of x for all x in I. If this makes sense, we will explain it further mathematically.
These on the board are the basic toolbox problems. They are the fundamentals for antiderivatives. You can reference them on reference page 6. These are numbers 2 through 4 and 6 through 7. Number 2 is one of the first ones that you will learn or that you should know. It is the integral of x to the n dx is equal to x to the n over n plus 1 plus c. Number 3 is the integral of 1 over x dx is equal to the natural log of the absolute value x plus c. Number 4 is the integral of e to the x dx is equal to e to the x plus c. Number 6, because I'm not number 5, is the integral of sine of x dx is equal to negative cosine x plus c. And lastly, there is number 7. The integral of cosine of x dx is equal to the sine of x plus c.
So the easiest way to figure out why you need a plus c is to go back to the derivatives, which you can find in chapter 2. So I'm going to show a quick example. If we have e to the x plus 6, and we're taking the integral, we know that it's going to equal e to the x plus c, as Vicky just showed. But now, how do we account for this 6 right here? That's why you put the plus c, because you're accounting for the variable that could be in the problem before it.
So here we're going to be taking a problem from our book and applying it with our toolbox problem, number 2, which is the integral of x to the n dx, which equals x to the n plus 1 over n plus 1 plus c. So we have here the integral of x to the 6 dx, and n, which is our exponent, equals 6. So I'm going to go ahead and write this out here. So the integral of x to the n plus 1, and what we're going to be doing is what we did down here. So now I'm just going to go ahead and plug the numbers in. So x to the 6 plus 1 over 6 plus 1 plus c. And that is x to the 7th over 7 plus c, which is your integral.
So I'm going to do what James just did and show you another problem using a toolbox problem. So this time we're going to use number 4 toolbox problem, which is the integral of e to the x dx is equal to e to the x plus c. So this problem we have is the integral of negative 79 e to the x dx. Okay, first what I like to do is take out the constant, this number right here. So I'm going to move it to the front like this. Oops, that's not enough. And take the integral e to the x dx. Now this problem is just a simple toolbox problem that we have down below. So this comes to e to the x plus c. And now I can bring down the negative 79 and times it by my integral. So my answer will be negative 79 e to the x plus c.
Another example of this is the integral of 18 cosine of x dx. Like Brittany said, the first step is to take out the constant. So we put the 18 on the outside, integral cosine of x dx. And because we already know one of our toolboxes is cosine of x dx equals sine of x plus c, we can assume that the integral of 18 cosine of x equals 18 sine of x plus c.
For a more complex problem, we have to evaluate the integral of t to the 7th minus t squared over 2 minus t dt. To evaluate this problem, or to solve this problem, you would have to take each of these individually, so that way you can understand that these are toolbox problems that we would use. For this one, this is just simply x to the n power, which you can evaluate as t to the 7th plus 1 over 7 plus 1. For this second portion, to make it simpler for yourself, just evaluate it as this portion being 1 over 2 and your second portion being t squared. So you would write it as 1/2, and because you have your t squared on top, when it's just t squared, you're going to write t squared plus 1 over 2 plus 1. And these will be multiplied together when you answer the problem in the end. And then you have to evaluate your minus t. So then you take this portion, and this is just simply as well the same one as this one, x to the n, which you will evaluate as t to the 1, because essentially there is a 1 there, plus 1 over 1 plus 1. And this is what you will have to simplify to equal t to the 8th over 8 minus 1/2 t cubed over 3 minus t squared over 2. And then of course you always need your plus c. Now, depending upon your teacher, you may have to simplify this area, so make sure you do it and make sure you understand if your teacher wants you guys to simplify it.
Thanks for watching our lesson. Hopefully now, because of our lesson, you'll be able to use toolbox problems to solve all these antiderivatives.
Go Ravens and Coke!